All right, everyone, it is now 2:30. Welcome back. I hope you've had hopefully a nice and restful fall break, and hopefully you're able to start it a little bit early with 290 going async. Today we are on lecture 9. Whether this is lecture 9 or lecture 10, I don't think we've decided if we counted the last async assignment as a lecture. So for now, it's lecture 9. So if you're looking for this stuff on the website, it should be under the lecture 9 header, and we'll post this after class. Today we're going to be extending the talk that Noah did last time we were together, which was on networking, and we're going to try and bring that towards a very practical and real-world application, and hopefully this will help you see how most modern applications, whether that be web apps and mobile apps, actually work. And we'll be talking about the tech stack as well. Before we get started, there are some announcements. So if you remember A6, which is networks, that was originally due the previous Wednesday before, and we extended that by 1 week. However, we are still accepting late submissions for this, so if you do not have a chance to submit it yet, feel free to do so. The asynchronous activity, which we assigned in replacement of having lecture last Wednesday, this should be relatively short. It's just about going through and trying to learn some techniques for finding good resources and documentation online. That will be due on Friday. So if you try to get this in, there should be no code. It's just going through some of the questions there. And then also, we sent out an announcement, I think maybe at this point 2 weeks ago, about the final project Airtable form. So you filled out this form to kind of express an interest in a topic. And there's also a section at the bottom for you to ask questions to us, if you had any. And so I went through those last night. I emailed everybody back who submitted a question, I think. So if you did not get your question answered, feel free to message me and I will try to respond. There's some good questions. Some people were asking about project ideas, and they all look very good so far. So thank you for filling this out. This form was not I guess, counted for any points, but it's just helpful for us to kind of gauge where everybody is. One of the things that we did see on the form is that there are a lot of students who are interested in the web development track. And so got an email over break by one of your classmates who had mentioned that the React tutorial part of that track was actually not free. I think it said on the as a button, sign up for free, and of course that was a bait and switch, and once you actually did it, it was just a free trial. We missed this, so I went in and I replaced it with what should hopefully be an actually free version this time. So I want to emphasize that and I said this in the announcement, we don't want you to have to spend money on anything for this course. So if something that we link to somehow brings you to something that you have to pay for, please let us know and we'll find an alternative for that. We want everything to be as accessible as possible. Now, some of the track tutorials that are included there, they do offer a optional paid version. So a lot of times in certain websites and certain certifications and the like, you can have access to all of the course material for free. But if you want to earn the piece of paper, that certificate saying that you did complete it, you do have to pay. So for the purposes, if anything like that is linked in any of the tracks, we're mainly talking about the free piece. That's all you have to worry about. If you want to earn a certificate or something as an optional thing outside of 290, feel free to do so, but that is not a requirement here. Any questions about any of that? All right. So again, some announcements. We're saying this every week. Hack and See, I'm assuming registration is still open. I hope that that's correct. That is here if you're interested. Also, another one that I added, sorry this is slightly late, is Reality Fest. I believe this is a AR/VR, it's called XR, kind of this combination of both. It is a conference hosted, I think, by the AR/VR Club, and that is happening this weekend on Saturday. So you can feel free to scan that and sign up if you're interested. AR/VR is a very big part of, there's a lot of research and a lot of development happening there in the computer science world, the software engineering world. We also, as a department, one of the main things that we actually specialize in, we have a lot of good researchers for, is video technology, so video recognition, AR, VR, etc. So that is an area where UNC is pretty strong. So if you're interested in learning more, if that's something you want to explore further, highly recommend this. And this will be on the slides available after class too. And Campy send an email about this. Another big announcement here, which is something that we wanted to start pubbing now, and we'll send this out. we will be collaborating with HackNC to host a HackNC workshop. This is going to be called Introduction to APIs, and it actually extends really nicely off of this lecture. So if you're interested in attending, this will be an extracurricular thing. So it's on Wednesday at 6 p.m. in SN14, which is a large room on the other side of the building. This is an extra credit opportunity. So if you complete this, we will add 10 percentage points to your final attendance grade. Now, if you're quick and if you know the syllabus and you do the math, that does equal, I think, 2% on the total grade. So if you missed a lecture, weren't able to get it excused, or you missed an assignment, this would be a great way to account for that. So highly recommend checking this out. I am 90% sure that there's going to be some sort of cookies and maybe some merch. I asked the HackNC people, and they gave me that certainty. Yes?
If you have 100% attendance, does it go like 110%?
Yes.
Okay.
Yep, it will. Is that the same question? Great. Yes. So there is no cap here. So if you're at 100 and you attend, it'll help you. The main reason is because if you have 100 in attendance but you are missing something somewhere else, it can help out. This will help out with final projects too. So we will have this out. Again, highly recommend attending because we will be doing some interactive coding, and APIs are one of the most fundamental things within software engineering, and computer science in general, that we want to talk about, and extends really well off of what we've done here.
Yeah, and if any of you are interested in doing HackNC, and maybe this is your first or one of your first hackathons, this will be a great resource too, because I know how nerve-wracking it can be sort of going in, not necessarily knowing what you need to know for the hackathons. Is aiming to get you to a point where you can actually outrun HackNC.
Yep. Yes.
What time is it expected to end?
It should be around 1 hour, so it should end by 7. Yep. And also another thing, in case this question does come up, you don't have to be registered for HackNC to attend. So if you haven't filled out that form yet, you can still attend. Any questions? Great. All right. And if you have questions about this, feel free after class to send something or add something to the discussion too. Discussion forums would be happy to help. All right, another thing which I wanted to do, because I think this will be helpful in general for final projects, because final project, the way that it's set up, there's these different parts, and it seems a little bit, it seems not too rigid or concrete in terms of actual dates. So we put some dates here, and this is already open, I think, as of maybe a few minutes ago on Gradescope. So it should say the due dates on Gradescope. I'm also going to go into Canvas and in the assignment section to put in the due dates of these pieces so that it should be easy for everyone to see in multiple different places. The first thing is that project proposal piece, and so that's going to be kind of the first deliverable. And this will be due, and I'm writing here Friday, so it's a bit easier because I know sometimes, say like Saturday at 5 a.m., you might confuse that with Saturday at 11 p.m. So we're saying Friday, November 8th. I think that's like 2.5 weeks away, so there's still a lot of time to work on this. And you can submit on Gradescope. So Gradescope, the instructions should already be there on Gradescope. So if you're wondering how to submit, you will do it through there. So we sent out an announcement for a GitHub Classroom assignment to accept the final project assignment. And that should create a repository for you where you can put all of your final project stuff in it, the instructions for all the different pieces and all the expectations and kind of a to-do list of what to do is also there. And I can go into that later and show everybody if you need on where to find all of this. But if you go to the announcement, the most recent one, you should be able to accept the assignment there. I'll put it again in Canvas somewhere else. So that'll be due then. Now this piece, which is the getting started tutorial and progress check. So the progress check is not something that we're grading, but it's more of a benchmark. So ideally, by this point, you should try and complete around half of what the getting started tutorial content should be. The reason why we put this here is we know that as you begin to near FDoc, there's a lot of things for other classes, whether that be 110, 210, 211, etc. There's a lot of work usually. There's usually some sort of project and finals to study for. So if you're able to complete a good amount of this early, then you won't have to stress out too much. So this is, I think, 3 weeks out, and then after that, there's another 2 or 3 weeks to complete the Getting Started tutorial. And what you'll also find is as we continue now through some of the future lectures, the number of assignments that we post, like how you have the networking one or whatever, it's going to decrease, where we want to give you time instead to work on this. So there will not be more regular assignments maybe every week. There might be a few things, but it should be less in scope. Yeah?
You not mean Elda?
Yes, I do. Thank you. Let's change that. Yes, LDoc.
Yeah, that F could stand for final day of class.
Thank you, Noah. Yeah, that's what I meant. That's what I meant. Yes. So yes, LDoc. Sorry about that. Yeah. So the final thing here at the last day of class will just be the final submission for the Getting Started tutorial on the project plan. That's kind of just finishing out the assignment, and that'll be submitted on Gradescope as well. And we'll open that in a few weeks. We want to make sure that everyone kind of focuses on these things first. Any questions about the timeline? Great. And if there's any questions regarding final project expectations, please reach out to us. All right, so we're going to get started with some content today. And I want to kind of pick up, because it's been now a while. It's been 2 weeks since our last meeting. So let's try and, remember the main key points there. Because last lecture, there's a lot of things that you learned about how the internet works, about different protocols, etc. But we really are only going to pick out a few key points here. The first one is you learned about how computers communicate through the internet, right? That the internet is this mechanism, along with networking, we use all these protocols, etc., so that computers can communicate with each other, right? And one of the things that you worked on with assignment 6, actually now that I'm reading this again, I think there was one announcement that called this A8. So whether this is A6, A7, A8, whatever it's called, this is the networking one. We apologize. I think I wrote A6 somewhere and A6 was used somewhere else, so don't worry. This is just a networking assignment. So in this one, you learn how to use HTTP requests, so using the HTTP protocol to retrieve data or retrieve kind of the HTML of a website. And in class, Noah showed using this curl command to do the same thing. The key idea here is just that HTTP is a way for a computer to request a resource from another computer, and then that other computer will return back some information, the information that we requested. How does that sound with everybody? Good? Middle? Good, okay. Perfect. So yes, this is kind of what we're talking about. The key idea here is that using these HTTP requests, we can communicate. One computer can communicate with another. You can make a request, and you'll get some sort of response back. And this is generally how websites work. So for example, if we go to Safari, I'm sorry, this is very zoomed out, I don't know why, and you try and search like the COM290 website, let me do that, COM290, and you click here, you see that we have this HTTPS in the front, right? We made an HTTP request to the server where this website is hosted on. We said that we want to retrieve the website so we can see it on our browser. And we get that website as a response from wherever this website is hosted for the computer that it's on, and we get it showing up here. So that's kind of that is how this relationship works. Does this kind of make sense? Good? All right. So and this is kind of, I think Noah probably talked about this actually 2 weeks ago and used this word server, and that's something that I'm going to be using from here on out. These two slides say some other computer, but from now we're going to use this term called a server. And a server is basically just a computer somewhere that provides resources to other computers on the network, right, that we call the internet, right? So oftentimes, computers are going to talk to servers using HTTP. And a computer will make an HTTP request to a server, and then the server will respond with with whatever we requested. So in the case here with our website, our computer is requesting this website from the server that it is running on. In fact, I think this is a GitHub Pages website. So GitHub, we'll say, is the server here. And we request this website from GitHub, and it returns back with our site. So that is, when we say a server, this is just another computer sitting somewhere. You have those big data centers, oftentimes with a bunch of these giant computers and servers. And when we're trying to use the internet, when we're loading web pages, all we're doing is we're making a request to the server, and the server is giving us what we wanted, which was the website. How does that sound? Good?
And a quick
Yeah.
refresher here, can anyone say, how do we know, like, how do we address a server? How do we tell it, like, this is a server that we're trying to access? Yeah.
IP address?
Yes, that's an IP address, and that rings a bell. Who doesn't remember this is a string of 4 sort of numbers separated by dots there. That's a unique address for every computer on the internet.
Yes, and do you also remember from last time, this is kind of a bonus thing, we type in this URL into our browser, and it gives us back this website. But what is the tool that converts this website address into an IP address that kind of points to where the server for this website is? Anyone? This is a bonus thing because it's an acronym, which is probably we haven't talked about today. So, Noah, do you want to refresh?
Oh,
Yep.
I saw one more hand again.
Good.
Is that company that like owns all of them?
Well,
Starts with
which
A?
A? I don't think that you might be thinking of something different. That one's a different
Think
one.
of AWS.
It's like the international one that
Oh, I forget
It's an
what that is.
ICANN.
It might be.
ICANN.
Yeah.
Yeah, close.
Yeah.
It's related to ICANN, but it's not actually ICANN. The system itself is called DNS for domain name service or system. I forget what that is, something like that. But the point is.
And I believe in AOC or whatever the assignment, the networking assignment was, you did use that, right?
Yeah, you have to look
Yep.
up the host name by DNS. Yeah.
So that's kind of the conversion that's happening here. Whenever we type in this URL, it's going to DNS, and the DNS is converting that to a IP address, and that's what we're ultimately, that's pointing to the server that we're ultimately trying to get the website from.
Right, and you can just think of DNS in your mind like a giant dictionary where the key is the website name and the IP address is the value.
That might be a bit of an Easter egg for 110 students. I think I saw on the 110 website that they're talking about this soon, either today or tomorrow. I don't know. All right. So the idea here is that in this diagram we have one computer making these requests and then getting a response from a server. But if you think about it, everybody in this classroom right now can go to the Comp290 website, and all of you will get the same website, right? We'll get the same page. And so that's where we can expand our model a bit and mention that there can be many computers that are making a request to the same server. And there's some work behind the scenes for making sure that everything is working correctly here, that all the computers are properly processed at the same time. We won't get into that in this class. But again, the key thing here is that you can have many computers talking to one server, and that server is going to give resources back to the computer. So if the computer requests a certain resource, the server will respond with it. Now, I kind of make that a bit ambiguous. What is a resource? That's kind of an open question. Maybe let's give a few minutes for everyone to kind of talk in your group. So what are the types of things that our computer might ask some external server for? So we'll spend a few minutes, we'll walk around, then we can discuss it a bit. All right, let's get back together. Did anyone brainstorm any ideas of what we might mean by resources? Have any thoughts? Let's see. Yeah.
like files.
Yes, files. So that is a big one. So files are one of the main types of resources, and the types of files that we can access, there are many different ones, right? So HTML is one, that's like a website, that's one type of file. You can even find PDF files. People can put PDF files online and you can get those. There's even a file format called XML, which I don't think that you probably have not seen. It's kind of a weirder version. It's like HTML, but with data instead of actual website components. So that's another type of file you may see. But yes, great. That is a great example. Does anyone have any other ideas? Yeah.
Like images, like audio and video.
Yes, exactly. Yes, so media, images, audio file. And I guess this all everything that we do talk about does end up being some sort of file, but that's a great example. So video is a big one, right? If you're going on YouTube, you search for a YouTube video. Sometimes it takes a while to load. That's because you've sent a request to the server, but the server, it's a very large amount of data, so it takes a while to get from the server back to your YouTube window. So that is a great example. Any other ideas? All right. Well, those are great. So files, media. Another big one which you might see is actually just raw data. When you are, for example, and we'll be exploring this later with weather data, for example, if you're trying to find, let's say that there's some, let's say with the hurricane, right? There's been a few, and they fly those planes into the hurricane. They collect all this raw data, which is just dumped into like a data file. There are actually ways to request, let's say from some sort of weather server or the NOAA or whatever the acronym is that the government runs that puts all the weather data on. That's another example where you can request data. They have a server, data's on it, you can request it and get a response back. Also, I realized my mic was off, so hopefully that wasn't a problem. But yes, those are great examples. And so I guess I don't have a slide confirming those, but yes, that is correct. I'll try adding a list in the next when we upload the slides. So remember back here, we said that a server is basically just a computer. It is a computer or a system. So if we're saying that a server is just a computer, then that implies certain things about the server, right? So if we say that a server is a computer, this means a few things. Well, if a server is a computer, then like a computer, it should have an operating system. And typically, this is Linux. Linux is a very special operating system that a lot of people like. Some people not so much, but it's pretty cool to play around with. Just like a computer, if you're on your computer and you open, for example, your File Explorer Finder on Mac, you have all these files. You have this directory structure, right? We learned all this stuff about cd, ls, all those commands in the terminal. Just like a normal computer, servers then have their own file systems. And this makes sense because as you had mentioned in the back, if you're trying to request files from a server, well, those files better be then sitting on that server so that you can request it. Another big one, and this is a key thing here. If a server is a computer, just like how computers can run programs and run code, servers can do the same. And this is kind of the functionality of servers. There's so many things servers can do. That's because they can run all of these programs. And there's a specific group of people, the back-end engineers, you hear that term. They're the ones who are often writing code that runs on these servers. We're going to explore a little bit more about what back-end means in a little bit. Another key thing, if we are asserting that servers are computers, that also means that servers have their own CLI, right? So command line interface, just like how your computer does, you open up the terminal, you can run all these commands, that means you can do that on a server as well. And this is really, really important because you can kind of see this, the diagram somewhat shows this, but if you imagine these large servers that are these big computers, they're sitting in one of those centers, right, data centers, they are probably not going to have a keyboard and mouse and like a screen that you can just like work on, right? They don't have that. So it's just a computer, and the only way that we may be able to interact with this, we don't have a mouse and don't have all the other accessories, is through the command line. And so this is a big motivation for why we learn the command line. It's not only so that we can control our own computers, but we're going to see soon is that we can actually access external servers and control them remotely using their CLI. So we're going to be talking about this in a little bit. Anyone have any questions here? All right. Let's see. I thought there was animation on this slide, so it hid all the text, but I guess not. So we'll recall something from Noah's lecture. So Noah mentioned in his in the networking lecture, right, that HTTP is not the only protocol that we use to communicate between computers. There's so many other ones. There's like that FTP protocol. There's the mail. Do you remember what that one is?
Yeah, SMTP, I think.
Yes, SMTP, the male one. Then there's this one, SSH, which is the Secure Shell Protocol. And we're going to be working with this a little bit today. And this is why a lot of the networking background that Noah talked about is helpful when we talk about servers. And what SSH specifically allows us to do is allows us to create a secure connection between two computers, even across maybe a network that's potentially not secure. And what this allows us to do is, using an SSH connection, we can actually control a computer or a server remotely. We can access the CLI, the command line, the terminal of this server from our own computer. And this is a very powerful thing because you have all these servers sitting there, maybe in some data center, or maybe you have your own server that you're working with. And since it doesn't have a keyboard and mouse, and it might not even have a screen, the only way that you may be able to connect into it is by taking your computer and kind of plugging this connection in so that we can control it remotely. Now, this is, of course, another type of connection. So we talked previously about HTTP, and then now we're talking about SSH. So I want to, again, highlight here the key difference, right? So HTTP is for when we are trying to request resources, so requesting files or requesting data from a server. It is kind of like, it's like a loop. It goes in one direction where the computer sends something from like we send a request from the computer to the server, which is like asking for some sort of data or some sort of resource or file, and then the server is going to respond with that resource, the one that we requested. And this kind of happens in this, it's a very procedural thing. Like this is step one, this is step two. But with an SSH connection, this is a more constant connection between both computers. And instead of trying to request data, we are instead trying to access the shell of this other computer. So today's activity, we're actually going to be looking at this and trying to connect our computer to a server. Any questions about the difference between these two? Cool. All right, so unfortunately, also the title is incorrect here. I'm going to say logging into the network here. So logging in, or SSH into a network. So one of the things that we discovered earlier is there's actually the information science school. So if you are either an information science major or you were in the past, they actually have a server that's school-wide called Opal, and it actually gives every single student their own access to this server. And so you can have kind of this custom private server for yourself. If you take one of the INLS classes, they turn on that access for you. The problem is I didn't realize when I was making this originally that that's only if you took that INLS 161 class or whatever. It doesn't actually give it to all students, which I guess makes sense because there's so many students, it would not make too much sense to have all these servers sitting there dormant. But because of that, we can't really. Originally, we were going to have everybody just SSH into the server that UNC gives you. But since we don't have that, Noah worked yesterday to create a makeshift version. So this is using Docker, of course, because Noah is the Docker expert. And really the idea here is that we're simulating this environment where we're creating a server using a Docker, and actually you might be able to explain it slightly better.
Yeah, it's basically just a server's operating system, like just running, in this case, since we're using Docker, it's going to run on your local device. But the way you'll connect to it is just how you connect to any other server.
Yes. So this is kind of simulating the real thing, and you'll be able to access your very own server using the same steps as you would. And then I'll show you how you do it with UNC's, just so that you can see both examples. So this will kind of be a workshop here. So I want everyone to try and run this command. I think Noah also posted it in the discussion forum. So
yeah, if you want to copy it out, it's in discussions on Canvas.
Yeah, that way I don't have to type all this stuff in. And so just open a terminal and we'll run this command, and I'm going to show you what this will look like.
And sorry, quick, make sure to open Docker before you run that command. If you have Docker Desktop installed, which I think is everyone in here, make sure it's open and running before you run the command, or else you'll get an error.
Thank you, Noah. I forgot that step. So yes, you'd open Docker. It would show up like this, and you'll have this window. So as long as you have this open somewhere, you will be fine. And I'm going to copy this in and run it just so you can see what the steps will look like here. So that actually happened instantly for me. It will take you, though, some time. It'll go through some installation steps. So try running this. And once you're done in Docker, you should see this SSH server right here. It should be green. So they'll add a new list item in your containers tab. It'll say SSH server, and the image will say Noah Smith S/SSH server. So we're going to walk around, and we're going to have everybody work on this. I don't know what is better if I should have. I guess if I do it this way, it's too small. I'll stick with this. That way everyone can at least see the command if you need it. We'll walk around and help out if you have any issues. Raise your hand if there's any problem. Is anyone still is it still downloading for anyone? Or are we good to, sorry, the light's kind of in my eye here. All right, I think it's looking pretty good. So now with this Docker, so I'll switch over to terminal. So we have this Docker image running, which is giving us a server that is now running locally on our computer that we can try and access using SSH. So this is kind of the same process. If there was a server somewhere else on the internet and you try to access it, it would be the exact same thing from here on out. So there's this command called the SSH command, and the SSH command allows us to open an SSH connection with a provided URL or endpoint or location that we're trying to access. And this is kind of nice because, of course, with HTTP, we had to use curl. It doesn't maybe sound as, it doesn't really seem like HTTP, but this SSH, the command is the same here, it's the same name. And so the URL that we're going to use is actually this one here. So I want to point out a specific thing, though, which is this 127.0.0.1. This is a very important address, and you can actually write this in two ways. So I'm going to close out of this. I'm going to write the other version, which would be comp290 at localhost. Has anyone seen this word localhost before in any of your time? All right, we got a few. So what localhost is actually referring to is that this is the address of your computer. So you have IP addresses where you are looking on the internet for a specific computer. However, localhost is a common term used to identify the computer that you're currently working on. So if, for example, you are trying to, let's say, run some sort of website and you want your website to work on your computer as you're coding it up, it will often run at the localhost address. So because that, if you're trying to make like a HTTP request somewhere, you'd usually type in some sort of web URL, like, for example, comp290 right here. But if you haven't posted your website online yet, you'll need to access it using localhost. So localhost is kind of the identifying word that we use for your computer, but localhost is kind of this, it's like a shorthand, it's like an acronym for, yeah, actually.
I was just going to say, it's just like any other website where like you have this DNS sort of, the idea of a dictionary and key, right? So when your computer sees that you're trying to look up localhost, it by default it doesn't go out to some other DNS server and look for it. It just resolves it to your local computer.
Yes, thank you. Actually, that's a great analogy. It's a good way to connect it back to. So here, yeah, this 127.0.0.1 is kind of the address that localhost is referring to. And so you can actually use either URL here and it will work. So I'm going to show an example. So we're going to go in to this brand new terminal. What you'll see here is you'll run this command and then eventually it's going to just stop running. You might also see this. You might see extra stuff added if you're on Mac after your name. That might indicate as well that everything is working. For some reason, that showed up for me after I started running the container. I don't know what the reasoning is there. But let's try it. So SSH, and we're using comp290. Do you actually have an explanation for why we have comp290?
Right.
Yeah.
So there's this notion of, remember when you log in, and like on any of your computers right now, when you turn it on, you have to log in. There's a username and a password. Usually your username is pre-filled. You just have to put in your password. But fundamentally, all operating systems, like all main ones, rely on this notion of users, and you have a password for each user. So when you SSH into a server, you have to tell it what user you want to connect as, because sometimes they have multiple users. So in this case, we have a pre-made user on this server called comp290. And so this is the format that you'll typically see when you SSH into something and you have a server, or you have a username and an IP. It always goes username at IP address, and that's just convention, and that's how you pass through the username and IP address all in one go.
I'm going to add this as well to the slides. So this is kind of our general template. General template, you have your username at the IP, or the address, right here. So thank you, Noah. All right, so let's do this here. So we have SSH. Com290 is the sample user that we have provided for you in your in the Docker image. And we'll just do this one, 127.0.0.1. You can also type com290 at localhost. It's the same thing. I'm just doing this to be, a little bit more explicit in showing how this is actually like a address that we're using here. But you can do either. And now you'll see that it's going to ask for a password. So just as Noah was saying, if you're trying to log into your computer, you have to supply a username, but you also have to supply a password, because otherwise I can log into any server with any as any user, and that could be very bad. So we have some authentication built in. And actually the password here is just an all lowercase password. So you'll type in password, and one thing you'll see here, and this I think showed up maybe one other time in the previous, when we were doing the CLI lectures, is that as I'm typing in my password, you may be typing, but you won't see any feedback. This is for security, but you are actually typing. So I'm going to hold down delete here. It's going to delete everything. You don't see it here. On this computer one either, but you can type in, right? PASSWORD. I typed it in. You don't see anything. That's just the way that the terminal handles passwords. If I press enter, you should see this pop up here with a bunch of information. So it says, welcome to Ubuntu. We have Linux here, which is, of course, the operating system that we mentioned that servers run in. And at the bottom, you'll see this. You'll see com290 was your username at SSH server, and then you'll have this $sign. All right, so I'm going to pause here so everyone can get to this step. So again, you type in SSH com290 at either this or at localhost, and then you type in your password.
Yeah, and sorry, one more thing to note here. Normally, any other situation where you're SSHing into something, if everyone here is typing 127.0.0.1, but this is a special IP, like Ajay said, that everyone decided, they said, okay, if you see this number, this just means our own computer, so it's a special reserved IP address. Normally, if you SSH it, if we had some sort of server that we had set up beforehand, and everyone SSH'd in, everybody in here would be connected to the same computer. In this case, even though it's the same, you're only on your own computer. I just wanted to make that distinction.
Yes, very important. So what again here, this kind of diagram, what Noah's saying is everyone has your own, right now, because the way this is set up, everyone is connecting to their own, like the server is running on your own computers. But in the real world, you'd be doing something like this. You'd be connecting to just multiple computers, would be connecting to one. And I'll show that in a little bit as an example.
Was everyone able to SSH in? Any difficulties?
All right, let's take a look.
I thought I did it, but I don't think it.
Oh yes, you can type yes and then press enter. Okay, so if you have some sort of pop-up that's asking about like a fingerprint, and there's like all this thing, and it says choose yes or no or something, type in yes and press enter. For some reason on mine it didn't prompt me. When I was testing it this morning though, it did, so I don't know why it's not here. So if you see something where it's asking you like a yes or no question, type in yes and then press enter, and then you can carry you said no. All right, so most of you are now here. And I want to kind of talk about why this is extremely useful and a little bit cool, because this connects some of the things that we've talked about so far. You'll see here that down here where we have this user at server and then this $sign, if you were to open any other terminal, let's say I just open a new window, right? And I kind of we'll zoom in here a bit. you'll see that, okay, maybe this is showing up. I'm not sure why this is. But on my normal terminal, you have a very similar window, right? Where you have your username, you have you have like something, either your computer name or something, and then you can start typing. So what we're actually seeing here is that this is the CLI, this is the terminal of the server. So we're no longer looking at the terminal of our computer, like our actual laptop or whatever. We're looking at the terminal of the server. So if we go back to this diagram over here, previously, well, okay, that's not the right thing. This. So this is what we're on, like this is the terminal that we were using, and now we're accessing the terminal of our server. I'm going to show now, if I were to type in ls, remember, ls just lists all the files in my server, and you'll see there's nothing. So my server is completely empty. There's no files in here at all. And so what I'm going to challenge you to do is try and add some files here using only, remember, we can only use the command line, right? This is our only window into this Linux computer that we have, right? Our server. We don't have a keyboard. We don't have a mouse. We can't even see the screen. The only thing we have is, well, I guess we have a keyboard. Yeah, we don't have a mouse. We don't have a screen. The only thing we have is the command line. So remembering some of those commands that we did, if you remember. Otherwise, I'll show it in a minute. Try and add a file here. Let's say just a normal text file like hello.txt. And see if that works, and then what happens as you work with different commands, like ls and etc. So I'll give a minute. We'll see. Okay, sorry. So that was Noah and I were testing something, so it would be cool to do a demo, but that didn't work because the Docker container is not ready. But anyway, so yes, we asked about creating a file. So let's say I add a file here called noah.txt, and we'll just write here like, actually, let me ask, does anyone remember the command that I have to write? So let's say I want to write the name Noah to noah.txt. Yes?
Could echo
Mhm.
Noah and then like arrow and then Noah.txt.
Exactly, yep. So echo Noah, and then this redirection arrow, noah.txt. And now, if we type in ls, you'll see that noah.txt is now a file that is sitting on our server. So the key thing here, this file doesn't exist on my local computer. This is on the server now. And does anyone know how I can, to confirm that it wrote the word Noah, does anyone remember the command to read the file name? Yeah, sorry? Yes, cat noah.txt. Perfect. And now, does anyone know the command for writing a folder, like creating a new folder? Does anyone? Go ahead, Noah. Yeah. Yes, let's go. mkdir. So, anyone have something that I should name this? Let's see. Have it open. Huh? All right. We'll say silence here. So, we create a folder. mkdir silence, I type in ls, you should see now that I have my directories and I have a file. So this is a file system, just like what I have on my computer, and this is sitting purely on our server. Another thing, because we did talk about this before, how back here we said servers can run code. So because Noah introduced this, I want to go into this rabbit hole a little bit. So this server, you can actually try this out. It has Python installed already for us. So if you were to type in like Python 3, this should open up a nice little Python console that we can start working with. So for example, let's say I create a variable. I'll say classroom equals FB09. We are in FB09, right? I hope so. Yep. And you press enter. And that saves my variable, and I can say, for example, print classroom. And what did I spelled it wrong. Okay, sorry, there's a typo there. Print classroom. And there we go, we have output. So this is a Python program, kind of, that we're starting to run code on our server. Let's say that I want to run this, like let's just say I want to say print FB09 and have a Python file. So I can write here, let me exit, so we can type in exit here to quit out of the Python this Python thing here. And let's say that I say not cd, echo, let's just say print hello world. So this is a string. This is a very, you shouldn't be coding like this, but I am for today. We're going to echo this print statement into a Python file. I'll call this test.py. What did I do wrong here?
He's trying to do bash string interpolation.
Is there any way that I can do this without?
Take out the exclamation point and see if that works.
All right, we'll try a different one so that it doesn't yell at us. Hello world. Without the exclamation point. The reason why that didn't work we won't go into because it's a bit of a rabbit hole. So yes, echo print hello world to test.py, and if I were to now cat test.py, you'll see that it prints out this. So my Python file now includes this one print statement. And in comp 110, to run a Python file, we can just run like python3 test.py. And you'll see that now we ran a Python program directly on our server. So the implications of this are really, really big because we can now, if we have a computer, we can technically start running programs on some distant server. And this is very useful, and I'll show some examples. I realize while you're doing this, feel free to just screenshot this window and submit it to Gradescope. I forgot to mention that there's this is a Gradescope attendance check. It says down here, submit to Gradescope for attendance. So any screenshot of anything that you're doing right now, feel free to post that up as long as there's some indication that you're that this green thing is there, that you're in the server, should be good. And if you have an error, I guess send a picture of your error and then raise your hand so that no one can help you. All right? Noah. All right, so I'll give everyone a second to do that. Apologize for not mentioning this earlier. Okay, yeah, yes. This is such a delight. There we go. So thank you, Noah, also for mentioning that this can run Python, because this is a good demo to do. Okay. Now I'm going to, I think, I do have time, so I'll mention this. I'm going to real quick show the other version. So I have access to the information science server. I did take that class that I mentioned. So I'm going to show this. If you for whatever reason took or are in INLS 161, you actually may have done something. You may have had to do this for an assignment. I'm going to just, also to quit this, you can just type an exit and that'll close your connection. That's another thing. So now we're back on our local computer and not the server. I'm going to try and SSH into this from memory. So the way that which might be a bad idea, but the way that this works is if you have an information science, if you're a part of the school, you would type in your onion. So that's my onion at, what is it? It's like opal.ils.unc.edu, I think. Okay, and now it's asking for my password. So my password is going to be my onion password, so what we log into Connect Carolina with. So let me do that. There we go. So you can see that now I'm in this, the Opal server. So Opal is the name of the server that it gives everyone. And we can ls into this, and you can actually see that I have two files. I have this auth file that was in there for one of my classes, and then I have this public HTML folder. And the cool thing here is let me cd into public HTML and ls. And you can see that I have a bunch of files in here. So I have some images, which I think was mentioned, right, of having images on our server. I have some HTML files for different things. And what this actually is, and what you do in the INLS class, is this runs, because this is already on the internet, the Opal server is run by UNC, you can actually make HTTP requests to this server. So unfortunately, the way that this is set up here, our local server didn't support it, but we can do it here. So I want to show you, if I just typed in, I think it's I hope it auto-completes, opal.ils, and then I think the squiggly line, and then my onion. This will actually request the website that is on my server. And you can see this is a very old, this is when I was a freshman, the first semester, we had to make this website. So here it is. That's like 5 years ago, that photo. So this is all of those files that were put on the server. I now have this website here. And that's the cool thing, is that when you are able to work with servers, you are able to put files on the server, and that is how websites work, essentially. Where you take your code, you put it on a server, and you can access. Let's see here, courses. Yeah, I have some courses. So that's the course that I was in, a store class, English, and intro Japanese. So, I mean, I don't really recommend trying to find this site. It's not that great, but it is something. So it's to show that you all, as you are. I don't know in the comp 110 210, you don't really get a chance to do this, unfortunately. But if you took comp 126 with Tessa, there might be a chance that she did something like this. But in general, hopefully, now that you have seen how this works, and maybe we'll provide some extra resources on this, you might be able to do something similar to this yourself and try experimenting with servers. That's a fun aside there. All right, so what I wanted to show though is how we made an HTTP request to this Opal server. So this here is SSH, right? Because I'm connected to the shell of this server, right? So that's kind of looking at this connection, this SSH connection. But what I did on my browser was this HTTP request. So I sent a request for the website. The server responded with this index.html, which I wonder if it says, we have to go to it again. Does it say index.html? It doesn't say here, but if I went to another page, it would say like /index.html there. So that's the file that was loaded. So this one right here, index.html, that is the file that was ultimately requested to the server. Any questions about this stuff? All right. So again here, the key thing here is, again, many computers can access data from one server. So if all of you tried to go to the Opal server and access my website right now, you all would be able to do so. And you're all accessing the same server, right? So that one server has that file, and multiple computers can ask for that resource. All right, so as I briefly discussed a little bit ago with different types of resources, resources don't just have to be websites. They don't have to be files. It can also be data. And an example that I used, and I want to come back to it again, is weather, right? Weather data. So what you can do is, if you have a weather website like weather.com or something, or you have that weather app, those apps. So an app on your computer that you download for weather, or an app on your phone even, or an app like a website, what's happening is all of those different apps or websites are going to a weather server, a server that stores the weather information, and it's requesting that data. And then the server is going to respond with that data. So that's why when you go into your weather app, it might spin a little bit. Or if you don't have an internet connection and you try to load the weather, it's not going to work, because it's asking an external server on the internet for data. It doesn't, on your device, it doesn't just, calculate, through all this math, calculate what the forecast is and then give it to you. It's asking a server to do that. So given this request, just to check for understanding, request and response, what type of request is this? HTML or, not HTML, HTTP or SSH? Which one? Yes, exactly, HTTP, good. So this is where we use now I want to introduce the word client. So we have here server. So let's say the server is responsible for generating the weather data. So maybe it's running the models, it's saying what the future forecast for Chapel Hill is going to be. That's all done on the server. And the server might even store information about certain locations, and maybe historical weather data might be stored on the server. And then individual websites, so whether you're on a website or you're on an app, this is requesting data from that server. Those different programs that are requesting data is called a client, right? The key idea here is, again, apps on your computer or on your phone don't calculate the weather themselves. It requests the server to do it. Why? Does anyone, let's kind of think about why this might be the case. Why would I not calculate the future cast of Chapel Hill directly on my phone? Why am I asking the server to do it? Yeah.
You could do anything else.
Yes, good. That is one. So having the ability to do other things on the phone. Anything else? Yeah.
The server has like a GPU and can process a lot better than my phone can.
Exactly. Yes. The server. Think about these servers are very powerful, large computers. Right? So when I'm doing something like crunching all these data points to try and determine a weather forecast, that's better done on a server which has a lot of power compared to a phone which doesn't have that much power. Yeah.
You probably don't need all the data that it has. Like you're probably only gonna look at the weather for like where you are, maybe somewhere, but not everywhere.
Exactly. Yes. Another good thing here. That's perfect. Yeah. So when you're looking on a phone or something, you're only really requesting one piece of data. You don't need all of it. So calculating all of it will be a waste. Another key thing here is, of course, with like historical data or whatever, as not only with computing power, but also storage. So if you remember back in the day on your phones, now we can have like a terabyte of storage on our phone. So I mean, storing like years of weather data on your phone actually probably wouldn't make as much of a difference. But back in the day, phones were very, phones are very small. So that the audio can match up. Yeah, phones were very small. You'd only have, I remember the days where it was like 16 gigabytes was all you could get on a phone. And so, that's not good to have all that data sitting there. Last thing is, of course, duplication of data. What's the point of having like the historical weather data for Chapel Hill on all of your phones, taking up all the space when it can just be sitting in one place, right? So those are all of the reasons there. So the key thing here is that when we request the future cast, or like request a forecast, your phone or the client is responsible for doing so. Remember, client is what we call the computer or the phone where that app is running. That is making the request to get the data. Then the weather server is going to try and get that data. So you're just going to calculate it, it's going to fetch it from somewhere, and this is done with code that's running on the server. So how we ran that very basic print statement, you have all this code that's actually crunching and calculating something, and then once it's done, it will respond with the data back to the client. Any questions about that? All right, so key thing here, how does an app or a website actually request data from an external server? It's going to use something called an API. An API, again, is one of the key, if you're doing any type of coding project for anything, even research or applications or websites, APIs they're like the key ingredient. And so we're going to be talking about this in that extra credit Hack and See workshop. We're doing it with them because for all of the students at Hack and See, learning about APIs will be very important. So we will mention that. Yeah.
An API that stands for Application Programming Interface, and very generally it just means any way that one program can communicate with another. And very oftentimes nowadays they're synonymous with sending some sort of network request and getting something back.
Perfect. Yep. So I highly recommend checking it out. It'll help tie things together and also be something really useful that you'll use in most classes. All right, so the last thing here that I want to focus on now is what we call the tech stack. So, you've heard these terms before possibly, of like front end and back end, client side, server side. And what this really breaks down here is how apps work. You think of an app like a weather app or even a weather website being just the code, like just the HTML, is doing all this stuff. But in reality, that's just one part, right? So that is the code that might be running on your user's device, like the app or the website where you can click around and do whatever. But there is this other half that we're now learning about where you have some sort of server. And there's code running on that server. And so the back end can calculate certain things. It can give data back to the front end. So your client can request data from your server. It's the same thing as on the previous side. But really, when we're developing and when we're coding now, we're thinking of two key halves. The front end, when we talk about front end development, we're really developing code for the client. So whatever the client is, the website, the app, it's the code that runs those things. If you do the web development track or the iOS development track, you're going to be in this side. You're going to be coding what the user actually sees. But there's a whole other half here, which is coding for the server and basically being able to calculate and give data back. So depending on what your client requests, you can calculate that and then return it back. That is all done with code. And so this is the back end. So back end is code running on a server, front end is running code on the device, and the bridge between these two is going to be this HTTP layer, right? So you have HTTP requests and HTTP responses. That's how your front end and back end communicate.
Yeah, and that is, I want to just, one small detail, that's like, this is very like web tech / apps. There are other protocols, sometimes HTTP, if you actually dig into it, is really heavy. It sends so much data that there's like, especially if you can think of a use case where your computer just needs to update its time. This is actually a separate protocol because people figured out, oh wait, we don't need all this HTTP stuff. We are only asking for a time. That's all this is ever going to be used for. So there's some other types of protocols, but HTTP is like the main one that you'll encounter a lot.
Yep, thank you, Noah. And yes, so this is a very simplified model. There are many things, as Noah is saying. As you get through the major more and more, you will begin to explore these different things. So again, key idea here is that most, like if you're looking at a web app or a mobile app or something, it's not just the front end, but there's also front end and back end. And together, this makes the tech stack. So you can think of it like a normal stack in 210s, like a stack of plates. At the top, right, is what you see. That's what the user sees. But there's all this code in layers below, like for example, the server, that your users might not see, but are very, very important. Any questions about this? All right. So the last thing here, I just want to extend the model that we talked about. So the key idea, just like how we had multiple computers talking to one server, is that ultimately how this will work is, let's say you download an app, right, from the App Store. You now have that client code on your device. And so multiple people may have a copy of like the weather app on your phone, but they're all talking to the same server or the same backend. So that's kind of the key thing here, is that not everybody has like their own copy of a weather server for themselves. There's one server that everybody's devices are accessing. And so when we work with, and as you'll see in later classes too, your front end, that's what the user sees, but there's really this one single backend where like data is stored. You may have weather, like historical weather data. You don't need it in everyone's, one for every single person. There's like one centralized place. And this is the simplified model that I work with. And if you're doing any software project, especially in like a lot of even the 400 level classes, this is the model ultimately that you'll want to picture. And we spend a lot of time in Comp 423, the Foundations of Software Engineering class, talking about this. So actually what you just learned here is like a very big preview of that class, because that class talks about the front end, the back end, connecting them together with HTTP. And so that's a very key thing. And then also, if you're interested, Comp 426, Modern Web Programming, focuses more on the front end part, so building websites. Also 433, the mobile development class, also is more front end. And then you have something like files and databases, Comp 421, which talks a little bit more about the back end. That is all that I have. I don't want to go too much over. If you have any questions, feel free to come up, and I'll see you all next week.